Hello, this is Eric Frisch with National Power Defense, and this is a short video just showing some of the testing I've been doing with the new power factor meter and some of the equipment that I have as well. This is pretty much a standard setup where we have the TransPower box. We have power coming in from the power company, basically here, going on into the TransPower box, coming back out through this power strip here, and down to the motor and light. I've also added an additional little heater there for tests. The purpose of this is on the power input side from the power company. I've added in a short strip that allows me to monitor the power specifically coming in from the power company and how we affect that. I have two tools. One is the oscilloscope and one is the power factor meter. Power factor meter data is also repeated on the computer screen here, so I'll be referring to that. The sine wave that you see here on the screen is the voltage sine wave. The line is the current sine wave. Now there's nothing on right now. I haven't turned on a motor or anything else, so you see no active sine wave there. I'm going to start by doing that. And I'm going to first turn off the motor and just have the light. I need to put the phone down. Okay, we're back. So this is just going to turn on the light. And you can see that there's a current sine wave there as well. And the current sine wave matches in phase the voltage sine wave. That's a power factor of pretty much 1. They're lined up beautifully. Here on the screen, you can see the lower numbers here are the power factor, so it's pretty much saying 1. And the phase is showing 180, which means there's no phase shift. Okay. Now, when I turn on a motor, you'll see a difference in that. Just Alright, there's the motor hooked up. You see the current sine wave is shifted by an amount called theta. Theta is basically what causes your power factor to reduce. Because you multiply those two sine waves together to get power, since there's a shift in it, you aren't actually getting, you're still using the same amount of current, but you're not actually getting as much useful work out of it. Here you can see that the power factor is also low. In fact, it's really bad. This motor is about 0.2 unloaded. This is a 1.5 horsepower motor. Now if I put a load on this with my foot here, you'll see the power factor improve some. Not much. It's a powerful motor. That's because a motor that's loaded more toward what it was designed to will have a better power factor. I'm going to go ahead and include or turn on the light at the same time here. Okay. Alright. And one thing I'm going to do is turn on and off the light, and so you can see that when you increase or add active power but no reactance, because the light has no reactance, you can see the light on, it actually improves the power factor. That's only because we're adding active power and not adding any reactive power. Okay, I'm going to leave that on. And you can see, in fact, that the power factor has improved to 0.5 from 0.2, a pretty big change. So now, we're going to go ahead and turn on the TransPower box and watch what happens. Ideally, we'd like to see that sine wave shift back so that it's in line with the voltage. You can see it's slowly moving. This is the processor taking time to add more reactive elements in there to correct. And you can see it's almost corrected. Now when we look back over at the power factor, you see it's 0.99. Now you'll see it jump around some. for two reasons. One is this is a demo box and does not have the full, all the features built in, and basically it's really designed to bring it close. But you can see it mostly hangs around where we say. Okay, next I'm going to add in an additional element. You see a heater. You see that there's quite a lot of noise on that current waveform. That's because I've loaded this thing so lightly that the Transpower box is almost to its lower limit of being able to operate. So what I'll do is I'll turn on the heater, and you'll see it cleans up a lot. It's brought it basically just about to its normal operating range where it likes to be, and cleans it up substantially and brings the power factor back into line. Thanks a lot for listening. It's been a nice set of experiments that I think helps explain how the system works.